It's Jen for Tested, here today with a home improvement project using our new X-Carve Pro CNC machine. So the last time we checked in with the X-Carve, Norm and I built the whole machine in about 2 hours and ran a first couple of test cuts just to get a feel for how it was working. Since then, I have been playing around with it, getting used to the settings and the software, figuring out some design ideas for projects we can make using the machine. So I've been wanting to make a sort of room divider screen thing for my apartment, and I thought that would be a good first project to tackle. It's sort of a 2.5D object. The form factor is pretty simple, and I thought it'd be a good way to get some practice with CNC joinery and, kind of arrangement of parts on the machine. This is the original idea that I had. This is not actually my sketch. I just made this real quick for you so I could show you what I was thinking, what was in my head. It's pretty ugly, but it's basically a long sort of ovoid shape, about roughly 7 feet tall, and I knew I want about 6 panels, and I want them to sort of accordion hinge so that I can position the room divider however I want, kind of rearrange it in the space. And the way I thought about doing this is to have a CNC frame made out of plywood and then stretch across the middle some fabric. This is sort of a faux rattan material. This is just like a plasticky indoor-outdoor material. But I thought I could stretch this across the frame inside of these little windows here. So the way that I plan to do that was have 2 panels. So each section will have a front and a back, and the inside will have a recess around each of the windows, and that's where I can staple in my fabric, so it'll be hidden on the inside. So from there, I started with a couple prototypes. So this is my first proof of concept, and it worked pretty well, actually. So I figured out how to get the 2 panels to sort of register together using some holes and pushing dowels into there. It's got a really nice 2-way hinge. This is like a little kind of a floating sort of hinge. It's not super rigid, but I figured I'll have 4 of these going up the side of each panel. And I also figured out this sort of puzzle joint. So another design challenge for this was figuring out how to lay out all of the pieces. This machine, this X-Carve Pro that we've got, is a 4x2 work area. So it's long and kind of narrow. There is a larger option for this machine, and there's also a function for tiling. So if you wanted, you could take a full sheet of plywood and pass it all the way through the entire machine. However, as you know, I'm sure you've heard, plywood is crazy expensive right now. So I thought I would make the most use of the material. So rather than laying out this whole shape on one sheet of plywood, I'm gonna waste all of this negative space and not really be able to use that material. So I thought, how can I make this as economical as possible? And basically, I figured out I would do individual sticks. So in this way, I can line up all of the sections, completely fill a sheet, and get the most out of my material. And in order to assemble it, I put together a little joint. This is it's kind of like a dovetail, but it's rounded. It looks sort of like a puzzle. And this will grab from both directions laterally and join all the pieces together. Both halves will layer on top of each other, and then the fabric can be in this little recess here. So that was the plan, and I worked through a couple different iterations in Illustrator, and we can show you some of that design process. And from there, it was on to Easel to start setting it up for cutting. So I'm here in the Easel software. This is provided by Inventables to talk to the X-Carve, and I'm going to import my SVGs that I created in Adobe Illustrator to put them into the CNC language. And you can see as I bring these into the software, there are individual components of my design that I can actually select and put different settings on them. So I'm gonna click on the actual shapes of each piece. And in here, there's a couple of different options. So I can clear out a pocket, which will carve out a section inside of a shape. I can also cut a shape on the path. I can cut outside the shape path, or I can cut inside. In this case, I want to cut outside. That way there's no real kerf. The end mill is just going to follow along the outside of my design. So we'll do cut shape outside a path. And you'll also see there's a color sort of shading, just monochrome shading here, and this indicates the depth of my cut. So if something is going to be cut deeper than another thing, it'll be a darker color. So I'm actually going to change this to the full depth of my material. This is 0.47, and you can see these changed to be black. Now these are gonna cut all the way through. You can also see in the preview that I'm starting to see those full cuts. Then I'm also gonna go in and select each of these recesses. So these are those channels that I added into the design where the fabric is gonna rest. And I'm gonna select each of those, and I can just shift click to grab them all. And I'm gonna set these to cut at 0.08 because that seems to be the right thickness. And I'm also gonna send these to the back. Now you can see in my preview, I've got a full cutout of each of my shapes. And if you look closely, you can also see the recess in all of the edges. And then last, I'm collecting all of these dowel holes, and I want these to be a through cut as well. Now, a little bit of finessing can be done here in terms of arranging these parts so that they cut the most safely and effectively. I have noticed that I can overlap the paths on two pieces, so these can sort of share a side, but I wanna make sure that these pieces, once they're fully cut through, they're not gonna come loose and launch out of the machine. The end mill doesn't run into them or they don't fly across the room. So I can add tabs to these, and Easel will automatically generate these if you turn tabs on. You can change the number of tabs, so I can make more, I can make less. I can change the length and the height of the tabs. So if you want a really shallow tab, you feel like it's gonna hold on well enough, you can also change the position. So occasionally I'll see like, this is not a great place to have a tab here because that's gonna be hard to file down. So I'm just gonna move that to a flat section of my design. I've also found that if you have two pieces that are sharing sort of a side, I can arrange it so that the tabs will be sort of right on top of each other, and they'll bridge that gap so that the material actually stays connected. So just carefully move that to overlap with my other tab. And actually, we'll add a couple extras here. It's a little finicky trying to select them and not select any of the other geometry, but it does work once you get a hold of it. Okay, so I feel pretty good about that layout. The next thing to consider are the settings for my actual cut. So I've selected a downcut end mill. This is just a 1/4" shank. And the downcut is gonna be useful because it will push all of the chips down. So I'm gonna get a nice smooth surface on the surface of my material, smooth edges on the surface of my material. So the downcut bit has some settings that are already defined in Easel for this material, which is great because it's a starting point for all of the feeds and speeds. I don't have to do too much guesswork. So I can go into here and select the 1/4" bit. They've already got a solid carbide, 2 flute downcut, and the settings are built in for my material, which is roughly half inch birch plywood. Then I can go into my cut settings, and I see here that I've got the feeds and speeds already populated. I've got spindle speed of 16,000, 38 inches per minute plunge rate, feed rate of 128 inches per minute, and this is all built into the program. There is some limitation here because when you get into certain more detailed areas of the design, I've noticed like in some of those tight corners, those tight puzzle joints, this particular setting is a little bit aggressive. You'll hear the machine kind of get higher pitched and sort of squeal in those corners, and there isn't any apparent way to sort of change the settings within one job. You're pretty much stuck with this. You can add additional tools for different areas if you wanted to do a roughing pass and then a detail pass, say, but pretty much with this one tool, I'm stuck with these settings. I should note, there is an option to import G-code. So if you have a more complex CAM software, you can create the tool paths, generate them, and then import those into Easel if you wanted to get a little bit more specific. For now, I'm just gonna go with the settings that they're giving me. I'm choosing a ramp, which means that it's gonna, instead of plunging at full depth, it's gonna gradually lower the end mill into the material as the spindle is going. So this all looks good to me, and I'm going to move over to a different computer, which is the one that's actually connected to the X-Carve. This is kind of a nice feature because it is browser-based, which is not always people's favorite, but it does give me the functionality to set up the designs on my home laptop where all of my SVGs are, and then move over to a separate machine that talks to this computer. Actually, before we head over to the other computer, I'm gonna go ahead and set up, fixture my material on the X-Carve. And I'm fixturing this ugly side up because this is gonna be on the inside of that 2-panel sandwich. So all I'm looking for here is just lining it up where I can get these holes. I can get my fixturing clamps on both sides of it. So one thing that's really important when you're fixturing the piece is to make sure that it doesn't interfere with the design. Otherwise you will, and I have already done, run through your clamps. These are made of plastic, so it's not a problem for the end mill, but ideally you don't want to run into them. So I'm just looking for areas where I can safely fixture these and there won't be any accidents. The last thing to do before I start cutting is to tell the machine where the material starts, where the front left corner is. So I'm going to jog the spindle over to the front left corner and the very top and tell it this is the 0 position for the start. So now we'll go to carve. This is going to go through a series of prompts just to make sure that everything that Easel knows is the same as what's actually happening in the real world. So confirm the material thickness. I know that the plywood is exactly 0.47. Material is secure. I'm going to confirm my bit. And this is to home the 0, just the way that I showed you. There is an option to do a probe with a puck. However, that requires you to be at the very front left corner of the work plane. And I prefer to kind of center the material, so I'm spreading out the use of the wasteboard around, not all in one area. So we're going to go with manual. I've already created the 0 point in the software, so I'm just going to say use new position, and we're ready to cut.
Hey, Jen.
Hey, Nor.
Hey, I heard the X-Carve running, and it looks like you're working on a big project.
Yeah.
Oh.
Lots of pieces.
How's it going?
It's going great, actually. I'm just about finished. These are the last couple sheets that came off, and Yeah, it's working out great. I'm happy with the design.
And,
I've
I mean, I'm looking at the size of the material you've put on the bed there, and also what's come out. I mean, you've been using it a lot.
Oh yeah, that wasteboard is definitely used up. So I'm not using the full width of the bed just because I had a whole bunch of scrap material that I wanted to make use of. And you know, plywood is pretty pricey these days.
Yes.
So I used what I had and I designed the length of each of the sections. Like I took my whole layout and then I cut it to fit this specific material.
Right.
So that I could fit as many on there as possible.
Kind of like you would with maximizing the bed of a laser cutter.
Totally, same
Yeah.
thing. Yeah, so right now I'm basically post-processing. So I cut all the pieces, they come off the machine with a little bit of like kind of burrs on them. And then all the little tabs where they were held into the main sheet, I've got to chisel those off first. And then I'll kind of go in with a file and just clean everything up. Yeah.
That's something we don't have to worry about with laser cutting, the
Right.
tab system, because the material just sits in place. The laser doesn't physically move
Exactly.
the material. Here, the end mill, it has a lot of action. What are you learning? Because I have no big experience with this. You know, what are the big fundamental differences or considerations
Yeah,
right, for something of this size?
There's a lot actually. So I'm learning a lot. I mean, as I'm looking at these pieces, I'm like, oh, okay, some of the qualities. So one thing I'm noticing is the quality is starting to deteriorate. I've been running this for days, and this is probably a few hundred of these pieces.
Wow.
So over time, the end mill will start to dull. Ideally, if the settings are perfectly fine tuned for your material, the end mill should have a pretty long life and could cut for like hundreds of hours. But right now I'm just using the default settings that came in Easel for this material. And I do notice that in some areas, like when it gets into these tight corners, like when you're designing for CNC, I try to make sure that the radius of all my curves is wider than the actual diameter of the end mill.
Or else you're gonna carve into it. Like
Yeah.
the kerf of the
Yeah.
end mill is gonna ruin your joint.
Exactly, yeah, like the design itself, but also like the chip load. So when it's stuck in that little corner, if there's too much pressure on like all around the end mill, it can you'll hear it. It'll start to like whine and have this really terrible grating noise. So it's like there's like with anything, like with laser cutting, there's a sort of average between efficiency and speed. So like you want to get, or I should say efficiency and quality, really.
Right,
Because
right.
you want to get, these big long passes, you can go pretty fast and just tear through that. But then when you get to these tight little corners, you don't want to be hogging out material as fast because that's a lot of work for the end mill to get into that little crevice. So
Yeah. When we do lasering, the two parameters we usually change: power and the speed of the
Right.
laser itself.
Right.
And the balance of that lets you, prevent you from singeing your wood. Or you do multiple passes,
Right.
right? You're trading time for, like you said, the quality. Here, the spindle rotation speed, right, is like your power, but also actually the diameter and the actual type of end mill.
Yeah, totally. So I've been using a downcut end mill, which actually in hindsight for these pieces is probably not the best choice. So the way I have this set up, this is the inside of my design. So there's two halves of the panel they're going to sandwich together. These recesses are going to be on the inside. So I did set it up that the nice side of the plywood is on the back, but because it's a downcut bit, the direction, so the flutes of the end mill are pushing the chips down, and it's actually starting to tear out, but it's tearing out on the nice side.
Oh,
And
right.
I can't
The
flip it
outward
because
facing side.
right, it's got
Yeah.
a carve in here. So I could have used an upcut bit, which would give me more tear out on the top, but the visual, like the side that you would see, would be a lot nicer finish. So.
The easy way to think about it, though.
Yeah.
Downcut affects the quality of the down-facing material. Upcut pulls it out. And this is a perfect example of that 2.5D
Yep.
cutting, right? Like this isn't something you could do with the laser cutter. You could cut the general outline of this
Exactly.
shape, but to have a perfect recess, that's why you would go with milling.
Yeah, no, and I mean, you could potentially cut something this thick on a laser cutter with
Yeah, a
many,
lot of
many
passes.
lots
Yeah,
of
yeah.
burning, but you also would get, I mean, you'd have the kerf of the laser, so this
Yeah.
has got, my joints, like I've tested a couple of these, they fit, they're super snug. You really have to like hammer it in there. So it works really well for, the 2.5D construction when you have more dimensional material.
The precision also of the software, and you're choosing where your kerf is ahead of time in the software,
Yeah.
as opposed to doing like a numerical compensation.
Exactly, yeah. There's not a whole, and you can cut on the path, and then you'd get the kerf, which would be the
width,
diameter
yep.
of the end mill. But yes, I'm cutting fully outside of it. Easel actually made it pretty easy. Like I've tried to do some cam tool pathing before, and it's like it's a little bit up here, but the process of taking this, like what we know in Illustrator and like translating it to laser cutting, all of those ideas about like assembly and you know, pieces, part tolerances and stuff like that kind of all ports over, and it's pretty streamlined to get from that in Easel to getting fully 2.5D pieces.
In your mind, you're still thinking
Yeah.
2D vectors.
Yep.
Basically, so that kind of progression from going like a vinyl cutter as an entry to vectors to laser cutting to now using a CNC, it's all the same kind of design.
Yeah, that's sort of how my brain that's the space that my brain lives in.
How are you happy with with the assembly, with the fitment, and you know, you cut to this size, but these things are supposed to be
They're
big?
huge. Yeah, it's going to be about 6 feet tall. I'll show you a finished panel, but yeah, they're going together pretty well. I have this dowel system, so when the parts, basically the joints where these puzzle joints are, they sort of stagger from one piece to the next. So there's never any place where you're going to have two puzzle joints on top of each other. They sort of stagger like that. So all of your structure, I'm gonna clamp and glue this whole thing together, and I cut 144 dowels to drive through all my registration holes, so everything should line up pretty well, and I think it's gonna work.
It's like furniture building. It's like, I think of like, it looks like, you know, IKEA, except you're going from beginning to end and making this your own. You mentioned plywood's expensive. We're all feeling that right now. Does that, you feel like that matters in terms of the quality of the output?
I think so. I sort of learned my lesson on this one. So I did use scrap material that I had, which was like, okay, plywood, but I ran out of that material and I had to go out and buy a sheet, and I was like, $100, $60. This will give you like a time reference of whenever you're watching this video. If it's years from now, you'll be like, $100 for a sheet of plywood. But yeah, that's where we are. So I bought the less expensive plywood, and I wish that I hadn't. I wish I had splurged for the more expensive sheet, because the tear out is more on the cheaper stuff. The voids, this was actually some of the good stuff, but the voids on the sides on the cheaper stuff are much more noticeable. And I'm a little nervous about when I attach the hinges, making sure that those screws grab. The more ply that you have for that screw to grab in on the side, the better. So in hindsight, like, this is my first CNC project. I thought I could get away with it, but all this time and effort, I should have just splurged for the better ply.
Well, yeah, you're worried about the quality of the finish, you know, the aesthetic you're going for, how things are going to go together. And unlike a laser, you're not going through a cardboard as a cheap analog to do a test run. Right. You know, you're going to cut your wood. I mean, and if you do MDF, that's particulate everywhere. Yeah. So also cleanup. Like, I heard also the shop vac going on. Yeah. So a note to the viewers about dust collection. So the X-Carve, as it ships out to customers, will have a dust boot on it, and you can hook that up to a shop vac. Ours is a pre-production unit, so we actually got this before they'd fully solved the dust collection system. So I've been going in and vacuuming out the chips, and I do think it's affecting the quality of the cut because the chips are all jammed, kind of stuck in there, but there is a dust collection system for this. We're just waiting to get the upgrade retroactively for our machine. It'll be part of our ongoing journey with the CNC. And you know, one of these sheets took about like 15, 20 minutes or so. Yeah, that actually gives me a really good idea of like the time spent design versus time spent, like how much do I want to spend. You always have to factor that in, like in the manufacturing, just waiting for the machine, and how much then cleanup you have to do. Totally, and every one of these pieces has to be chiseled and sanded and finished and then assembled. So it does add up. But I thought this would be a fun project to tackle as a first-time CNC build. So wow, ambitious, so ambitious. I can't wait to see this as your finished set. Yeah, I know there's more material you're waiting for to get this to work. So we'll do a little bit of a check-in later. Yeah, and hopefully see a finished one. All right, I've got one half completed. This one I finished up earlier, and this is the back, this is the front. Well, I guess it doesn't really care which is back and front, but the point is, this is the part where the fabric is going to attach into, and I want to do a little dry fit to make sure that everything lines up, all my registration holes are in the right place, and see how it looks. All right, moment of truth. Do all of my registration holes line up? I sure hope they do.
Looks pretty good. So the way that I'm gonna attach this together to kind of make sure everything's in registration is with some dowels. So I went ahead and cut 144 wooden plug dowels, and I'm going to just try a few of them, just make sure everything is in the right position. There it is. And then the last trick is this, which I'm really excited about. I just bought this little flush cut saw, and then I will slice off Look at that. Look how nice that looks. Yeah, I think this is gonna work out really well. So I'm waiting on the fabric, and once that gets here, I can then staple that into all of the recesses, glue and clamp this whole thing together, dowel it up, and it'll be ready. All right, so I'm here with the final piece. I'm about to show you what this looks like. I actually haven't seen what it looks like yet, but since the last time we checked in, I got this fabric. This is the sort of like faux rattan woven stuff, and I stretched that into the sort of the inside channel of the two panels, stapled it in, and then I doweled and glued the whole thing together. I used that flush cut saw to cut these dowels nice and flush, gave the thing a quick sand, and I attached some hinges along the sides here, which will allow it to fold and open in both directions. So let's take a look and see how it turned out. All right, so I think this panel opens like that. All right, what do we think? Cool, all right. So it stands up on its own. I think it looks pretty good. Every time I try something new on a new machine or a new piece of technology, I'm super excited when it actually works, and it actually works. So yeah, first major CNC project on the X-Carve plywood room divider for my house. I'm probably gonna finish this up with some paint or stain. I haven't decided yet how I wanna finish this, but you can check that out in the final montage. Thanks for watching. We'll see you next time.